Related rates, Pythagorean theorem application, and got it. What this question is all about. It's very similar to the previous question, right? It says Sam and Peter walk away from an intersection along perpendicular roads. Their walking speed is 4 kilometers per hour and 5 kilometers per hour respectively. If Sam begins walking 10 minutes before Peter, at what rate is the distance between them changing an hour after Sam left? So it is kind of similar problem which we just did. The only thing is that they don't start walking away at the same time. Sam begins walking 10 minutes before Peter. So that is a kind of twist. I'd like you to read the problem, make a sketch, define your variables, write down what is given to you, and then find out what is needed to be found. Once you've done this, then listen to my suggestions, right? You can pause the video now, do your work, and then look into my suggestions. So that will help you a lot to ensure that you are understanding what we are all trying to understand, okay? Here is my suggestion. So I'll again make a small sketch, right? And that is my sketch. Now, we'll say Sam and Peter walk away. Let's say Sam is walking in this direction, and we'll say Peter is walking in this direction from an intersection along perpendicular roads, and these are my perpendicular roads. Their walking speed is 4 kilometers per hour and 5 kilometers per hour respectively. So Sam walks with 4 kilometers per hour and Peter with 5 kilometers per hour. If Sam begins walking 10 minutes before Peter, 10 minutes before, so Sam really walks through all the time. At what rate is distance between them changing an hour later, an hour after Sam left? It really means that Sam walked for an hour. Let's say Sam reached here after an hour. But Peter started late. So Peter actually walked for, so time for Sam actually will be 60 minutes or 1 hour. And for Peter, time will be how much? Time will not be 60 minutes. It will be 50 minutes. So it will be 50 over 60 parts of an hour. Remember that. So this is the real change in as compared to the previous question. Do you understand? Otherwise, it's exactly same question, right? So now let's just draw a diagonal here without really bothering from where to where, right? This is what it is. Now at any instance of time, let's say this is x, this is y, and this time we'll take this as s. We'll not take d, so because we'll avoid dd, right? So that is how it is. Now let's write down what is given to us. Change in x, rate of change in x is, so we have dx dt given to us as 4 kilometers per hour, and we know dy dt is 5 kilometers per hour, 5 kilometers per hour, and we want to find after an hour what is going to happen. So when it is after an hour, Sam has actually walked for an hour. So the distance Sam covers, that will be x for us, will be 4 kilometers per hour times 1 hour, right? So that means a distance of hour changes, cancels, and we get 4 kilometers. Do you see the units? And as far as y is concerned, it will be 5 kilometers per hour, and the time is really 50 minutes because Peter starts 10 minutes late. So Peter really doesn't walk for an hour. So it walks for 50 minutes. So 50 over 60 times hour cancels. And what do we get? 0, 0 cancel. We get 25 over 6 as y value in kilometers. We do all this, right? Now, what is s equals to? Now, s is equals to square of these two and then square root. So we'll calculate s here. So s is equals to square root of 4 squared. And let me write 25 over 6 in decimals, right? And then points, and then we'll do square. Okay, 25 divided by 6 equals to, so it gives me a value which is 4.17, let me write, plus, let's say 4.17 square, okay, right. Now we'll calculate this value. So we'll say square of this plus 16, which is square of 4. So whatever we get, we do square root of, that is 33.36, and we do square root of our answer, and we get 5.77. We get 5.77, you can say 6. So that is what we get as S at an instance of time, which is an hour later Sam left this intersection. Do you understand now? So we got all this on the side. Now what do? We write down the relation, which is S square is equals to x square plus y square. And third step is differentiate both with respect to time. So when you differentiate both sides with respect to time, we get 2 times s over ds dt equals to 2x dx dt plus 2y dy dt, correct? Now we'll simplify this. We really want to find what ds dt is, and that too after an hour Sam left. So we'll say ds dt is the separation between the two, and the rate of separation is ds dt at t equals to, I will write 1 hour for Sam, okay? That is what it is. Now is really equal to, when we divide it by 2 we get x here, so we will have x over s dx dt plus y over s dy dt. I hope the steps are absolutely clear. I'm taking my time to make you understand each and every step, right? Normally I don't do with all the videos, right? Because I want you to just get an idea, a hint, and then solve them yourself. And this time I'll not calculate the answer, leave it at this stage. So x is given to us 4, we'll plug in 4 here. S is 5.77776, and dx dt is 4 again for us, okay, plus y value is given to us as 25 over 6, which is 4.17. 4.17 divided by 5.776. I don't know why I'm writing 3 decimals, but that's okay now. And dy dt is 5. So that is your answer. And the units will be distance over time. So don't forget that units will be kilometers per hour, right? I'll appreciate, calculate this, right? And take it as your test problem. Calculate this and write down your answer. Let us say to 1 decimal place, right? That should be fine. But the idea here is, I hope you understand what we are trying to communicate. The main thing is that they may not start at the same time. If they start at different times, then this is how you have to take care of it, right? Another thing is unit conversion, right? Minutes to hours, wherever possible. Conversion of units. So those things are kind of important, and writing answer in terms of unit. So this was a neater approach. What we did, we really knew what we have to do, right? So we knew we'll need all these values. We put them on the side, and then connect with the help of formulas, separation with this, and that's application of Pythagorean theorem, right? Differentiate both sides with respect to time, related rates, and link them. Substitute all the values to get the answer. These are the steps to be followed, right? To start always with a neat and clean diagram which explains everything. Define your variable. Let x be the distance along horizontal x-axis, showing distance traveled by Sam, walking at a speed of 4 kilometers per hour. And along the y-axis, let y represents the distance traveled by Peter at the rate of 5 kilometers per hour, who walks for 50 minutes. And then you can continue doing the rest. I hope it explains how to do these kinds of questions, and we'll get some more involving cars this time, but similar things, okay? Thank you and all the best.